All right, so this is an example on taking the difference of two normal random variables. So um, we are in, we're doing speed dating here, and the average height of a male speed dater is 70 inches with a standard deviation of 3.5, and the height of a female speed dater is has a mean of 65 inches with a standard deviation of 3. What is the probability? Let's make sure we read the final question. What is the probability that a randomly selected male speed dater is taller than a randomly selected female dater, assuming we're pairing opposite sexes like that? So let's define our random variables. Let's let M be height of male, F be another random variable F, and these are the random variables we're going to combine, and that's the height of a female speed dater. And then, so this qualifies as your state, just setting up your random variables. That's really important. And if we want to know if one is taller than the other, what we have to do numerically is find out the difference and make sure the difference is, if we want to know if, for example, male is taller than female, then M minus F has to be greater than 0, right? So we want to find the probability that our new random variable, the difference, D, we'll just say it verbally, the difference D is greater than 0. Now, there's nothing wrong with doing the other direction. You could do female minus male, and then what would this be? The probability of the difference is less than 0, right? It totally does not matter. You'll get the same answer either way. I like to keep the answer positive, so I'm going to try to put the bigger number first, but it's totally up to you. So let me just get to the end of this. What kind of random variable is this? Discrete or continuous? It's continuous. Yeah. You're not just like 63 inches tall or 64 inches tall. You can be 63.9 inches tall. So at the end, almost the last step, we're going to use normal CDF to find the area under the curve. Normal CDF. And what's going to be our lower bound? Let's just go to the last step so that we don't get lost in the process. If we want to know if the outcome is greater than 0, our lower bound is greater than 0, so 0, right? And our upper bound is infinity. Yeah. And then here is going to go the mean of, I want you to get used to the symbols, the mean of D, and this is going to be the standard deviation of D, the random variable, which is the difference. So all we have to do is find the new mean and the new standard deviation and plug it in, and we're good to go with everything we've learned so far. So armed with our formulas, we have the new mean is going to be, we're just going to subtract the mean male minus the mean female. You know what I mean? The mean of female. So you just go 70 minus 65, which is 5 inches, right? So that goes in here. That's 5. And then now, careful with the standard deviation, you cannot just subtract them for sure. In fact, you always add with variability. So we go through the variances. So you're going to do the variance of male height plus variance of female height. So be sure that you make a note that you're adding, not subtracting. Like Pythagorean theorem, you would not subtract a squared minus b squared equals c squared is not a formula. So just the variance is 21.25, but don't forget to take the square root of that, square root of 21.25. So you'll get about the variation of the difference. On average, the differences will be about 4.61 away from 5. So the average distance is 5 with a standard deviation of 4.61. And we want the differences to be greater than 0. There's a good likelihood that they're going to be greater than 0 because 5 is the average. So if you do that on your calculator, you'll get about 0.8610. And so there is about there is a 86% chance, this would be our conclusion, a randomly selected male speed dater is taller than a randomly selected female.